Alright, this video is actually continuing our series on stoichiometry. Here's the notes from Unit 6.2 I've got out again. We've already worked number 1, number 2, and number 3. So really, I guess if we was going to say anything, this video today is about percent yield. That's what we're going to be looking at in here. So, percent yield, let's go ahead and we'll start off the notes. I'll write a little bigger. So, percent yield, and there's going to be 3 types of percent yield questions. Now, there is an equation, percent yield equals, I like to write this way, actual over theoretical times 100. Now, that's like your stock percent yield equation is that equation. Ah, lovely, the bell just went off. Anyway. Now, what's funny, the only time I write the equation out pretty much is usually on one where it asks me for percent yield. But anyway, I'll show you what we're talking about here in a second. So, we're going to go ahead and do number 4 off your notes. There you go. If you can read number 4, that's good. If not, you can order a transcript from all these notes from turdferguson.com. Thank you. Anyway, now let's back up. And let's see if we can't do number 4. Number 4 says, a student in lab mixes 2 grams of magnesium with 1.5 grams of hydrochloric acid, which reality we would do later on, molarity and some other things. But anyway, so here's our problem. We've got Mg plus hydrochloric acid, and that yields single replacement MgCl plus 2 minus 1, so that's a 2. Plus, now the H is going to be all by itself, which means the H is going to be H2. Before we can do any stoichiometry, this has to be a balanced equation, so I'm going to slide a 2 in front of the HCl. So now we got our balanced equation. Now this problem says that we've got 2 grams of Mg, and we've got 1.5 grams of HCl. So, we've been given 2 things, so automatically you need to be thinking, LR and EX. I've got to figure out one of those 2. Alright, this is what makes this problem different than the other ones you've done, is this next part. The student then recovers 1.5 grams of MgCl2. The student, 0.15 gram. So this problem says, keywords, I'm going to write it somewhere off to the side here. It says student recovers 0.15 grams MgCl2. So here's what this problem's telling you. This part where it says recovers, that's telling you the actual. That's what this student actually got in lab was 0.15 grams of MgCl2. So that is your actual yield. So here's the thing. This is our actual, and I usually write this under it. Like I'll write actual equals 0.15 grams of this. That's my actual. So what I need to know is this. Every time we've written that question mark up there, that's our theoretical. Every time y'all have done that, that's what we should make. Here's the thing about lab. We never make what we should make. Usually, something evaporates, something spills, something gets poured down the sink. Something happens, and it causes your percent yield not to be what it should. So what it is this. We want to know how good this lab is. And it's really not how good the lab is. Some labs you do are only going to be like an 80% yield. Alcohol, for instance. If you're trying to do a production of alcohol lab, you're never going to get 100% yield because the alcohol, some of it's going to evaporate. About 78% is as good as you're going to do. So, here's our problem. We need to jump from the Mg, so I'm going to do the problem twice. I'm going to jump from the Mg to the MgCl2, and I also have to jump from the HCl. So I've got a limiting reactant problem here. So I'm going to start this problem off first with 2 grams of Mg. Draw my line, put my X, draw my line. Magnesium weighs 24 grams per 1 mole. Put my X, draw my line. My molar relationship is 1 mole to 1 mole. So for every 1 mole of Mg, I will make 1 mole of MgCl2. Last step, convert moles of MgCl2 to grams. So for every 1 mole of MgCl2, we should make chlorines 35 times 2. There's 70 and 24. So that's 94 grams of MgCl2 equals, and I am going to break out a calculator for this. So basically it's going to be 2 times 94 divided by 24, and that is 7.83 grams of MgCl2. Now, I'm not putting a box around that. I don't know if that number's any good. So now, to do the problem again, this time with the 1.5 grams. So, we'll just do this problem again. 1.5 grams of HCl. Draw my line, put my X, draw my line again. Here we go. First step, before you can jump, you have to be in moles. HCl weighs 36 grams of HCl per every 1 mole of HCl. Next step, we're in moles, so we're ready to jump. For every 2 moles of HCl, I should make 1 mole of MgCl2. So, my relationship is for every 2 moles of HCl, I will make 1 mole of HCl. Now, 1 mole of, forgive me, MgCl2. Put an X, draw my line. For every 1 mole of MgCl2, do my conversion, there's 94 grams of MgCl2. So let's see what this one says that we should make. And again, we've already done this in other videos. 1.5 times 94 divided by 36 times 2 is 72. Divided by 72, basically 1.96 grams of MgCl2. So, whoa, we got a little twisted there. So we go back to basically making biscuits again. I got enough magnesium to make 7.8 grams of MgCl2. I've got enough HCl to make 1.9 grams. Well, which one am I going to make? This is the one I'm going to end up making. So that means that this HCl is my LR. Magnesium is my excess. So I'm going to go up here. HCl, LR, that's my EX. And now here's what it's going to tell me before I do this problem. That is my theoretical. So in this problem, I should have made 1.96 grams of MgCl2. But it says somebody in lab only recovered 0.15. So what is the percent yield in this problem? Well, percent yield equals, and I'm going to write the equation again, actual over the theoretical times 100. And this is your most basic percent yield question. So, percent yield equals the actual, which the actual yield was 0.15. The student recovered 0.15 grams of MgCl2. They were supposed to, in theory, they were supposed to make 1.96 grams times 100. So all this is a percent. So 0.15 divided by 1.96 equals 0.0765 times 100. 7.65. This is a horrible lab. 7.65% on their yield. Anyway, so there is our percent yield for this lab. So once again, there's our equation, percent yield. actual over theoretical. Actual is what you recovered. It's like in our copper lab. The actual is what y'all weighed out in the lab. The theoretical is what you were supposed to make. So you do your stoichiometry to tell you your theoretical. And we found our LR and our EX. We used our LR. That's our theory. I still need to do something. Bam! Get out of there, 7.83. You don't belong. It's like 64 biscuits. It ain't going to happen. Wow, I forgot I'm putting this on YouTube. Anyway, so hope everybody has this. There's going to be 2 more videos to go with this percent yield one, though. Because now I'm going to teach you in the next 2 videos what to do if the problem gives you a percent. So this is an example of a problem where you find the percent. Hola, buenas noches, and como esta.